Okay, so four important situations that you should know about and some terminology throughout these slides. The first term is vertical angles. And the big thing about vertical angles is that they're always equal to each other, okay? And a picture of vertical angles is whenever you get two intersecting lines, and if they intersect, they form the letter X, okay? Angle 1 and angle 3 are going to be congruent to each other. 2 and 4 are congruent to each other. So that's vertical angles. Just remember, look for the letter X. If you see two lines intersecting forming the letter X, you're looking at vertical angles. Complementary is two angles whose sum is 90. Supplementary is two angles whose sum is 180. Complementary, 90 degrees. Look at this diagram here. Okay, you see you have that 90-degree angle and two angles that add up to it. Okay, that's complementary. Supplementary, since 180 is a straight line, it's two angles that make a straight line. Now, sometimes some students get confused between what's complementary and what's supplementary. Well, one easy way to remember it is just as the letter C comes before S in the alphabet, 90 comes before 180 with the numbers. So complementary means two angles that add up to 90. Supplementary, two angles whose sum is 180. And a linear pair is two adjacent angles. Now, adjacent means next to, okay? Like your next door neighbor is your adjacent neighbor. Adjacent means next to. So two adjacent angles, they're next to each other. That means they share an edge in common, a ray in common. And together they make a line, 180-degree sum. Okay? So those are the four important angle types that we're going to talk about now. First, if you have a 30-degree angle, what is the complement of a 30-degree angle? Well, remember, 30 plus what equals 90, or 90 minus 30 is 60. And what is the supplement? Well, let's do all complements first. What's the complement of a 53-degree angle? 90 minus 53 is 37. And what about the complement of a 77-degree angle? 90 minus 77, which is 13. So just remember, complementary means adds up to 90. So if you subtract the one you're given from 90, you get what the other would have to be. It kind of makes sense, right? 30 and 60 add up to 90, 53 and 37 add up to 90, 77 and 13. Now, supplementary is the same exact process, but this time we add up to 180. So what's the supplement of a 30-degree angle? It's 180 minus 30, which is 150. Try the next two. Okay. 180 minus 53 is 127, and 180 minus 77 is 103. Okay, so those are pictures of how to find numerically complementary and supplementary angles, and that's doing it by just hearing the words and using the vocabulary. Sometimes we also have to do it by looking at pictures. So in each of these cases, the major angle, in the upper diagram, angle EFG, in the middle diagram, angle POR, in the last diagram, angle, I don't know what that says, IJK, I guess, I don't know. They're all right angles, which means the two angles on the inside are complementary. They add up to 90. So from this picture, even though we don't say, hey, the angles are complementary, we don't say angle EFH and angle GFH are complementary, you should be able to realize that they're complementary by looking at the picture. So what I'm looking for you to do is, in the first one, find the value of X. Do stop and start. Okay, so angle X plus 30 adds up to 90. So 90 minus 30 is 60. And that's the value here. And that makes sense, right? 30 and 60 adds up to 90. I'll do stop and start on the next two. Go ahead. Okay, next, 90 minus 55, which is what you have right in there, is 35. And next one is going to be 90 minus 40, which is 50. So that's how you find the complements in each of those angles. Now we go up to linear pairs and supplementary. So you'll notice in each of these diagrams, the angles on the left and the right are adjacent. That is, they share an edge in common. And you'll also notice that they form a straight line, which means they add up to 180 degrees. For the top one, if I want to find the missing angle here, angle CAB or angle BAC, notice we can't call this angle A here because there are actually three angles at A. The one that they tell you about, which is 94, the one on the right that we're looking at, and then of course there's the straight angle CAD, which is 180. So we just want to know angle BAC right now, or CAB, And to get that, it's just going to be 180 minus 94, which is 86. You try the next two. Go ahead. Of course, you're doing a stop and start. So for the next one, 180 minus 65 is 115. And for the last one, 180 minus 75 is 105. Okay. So now what I want to do is take a quick step back, and I just want to do a little bit of a quick equation review. So here are 4 equations that I'm hoping everybody can handle. So why don't you get started on those equations right now, and I will go over what the correct answers are with you in, well, you're going to do stop and start, and then I'll go over each of the steps with you, give you some hints behind them, and then I'll tell you what to do if the equations did not come easy to you. All right, so the first one, we want to get letters on one side, numbers on the other, okay? So that means I want to add 7 to both sides. That gives me 5n is 15. And then I want to get the n all by itself, so I'm dividing by 5, and that gives me n is 3. I call that a standard two-stepper. It should be pretty predictable, pretty straightforward. Next one, opposite side, opposite operation. What I am noticing here is that I always look at the variables first. The 2n and the 5n are on opposite sides. Whenever they're on opposite sides, you want to do the opposite operation. And what I'm doing with that is I'm going to get rid of the smaller number of n's first. So I'm going to subtract 2n from both sides. That gives me 3n minus 4 equals 17. And then you'll notice that this looks exactly like the previous question with the numbers slightly changed. Add 4 to both sides. 3n is 21. Dividing by 3, n is 7. So in this case, I want to emphasize the variables were on opposite sides, so I did the opposite operation. Next one. Now I look and I notice that the x's are all on the same side. Same side, same operation. So 3x and 8x is 11x and 1x is 12x. In other words, I'm going to put them all together since they're on the same side. Whenever they're on the same side, just group them together, combine the like terms. That gives me 12x plus 4 is 28. Now, sometimes we get caught up in saying when solving an equation, whatever you do to one side, you have to do to the other. But that's not true when it comes to grouping. Okay, the step of grouping together might be done on just one side. Okay, minus 4 to both sides, 12x is 24, dividing by 12, x is 2, or I wrote n is 2, but it's x is 2, same thing. And in the last case, I wanted to make sure that you realize whenever you see a number outside the parentheses like this, you're going to distribute that number. So that gives 3x minus 9 is 18. Add 9 to both sides. 3x is 27. Dividing by 3, x is 9, or n is 9, whatever it says. So here's the deal. Each of those equation types should be pretty straightforward. You should know everything in this box. You should be able to ask yourself, are the variables on the same side or are they on opposite sides? If it's the same side, you do the same operation. That is, you combine like terms. I always look for that first. If it's on the opposite side, you do the opposite operation. Again, looking and focusing on the variables first. An equation is like a scale. You must do the same thing to both sides. Like over here, the minus 2n's, the plus 4's. Over here, the plus 7's, the divide by 5's. Except when we're talking about grouping things together. When you're combining like terms, you can do that on one side and not the other because you're not changing anything on that side. You're just rewriting it, that's all. If you see a number outside the parentheses, like this a and the b plus c, or in the last question, the 3 and the x minus 3, just distribute. Do it right away, get it over with. Yes, it's possible to do it without distributing right away. Let's not even go there. For now, we'll just distribute it and get it out of the way. Here's the key, okay? I taught a basic algebra class last semester, and by now, these should all be comfortable to you. There's nothing wrong with you if they're not comfortable. It's been a long time for a lot of you since you've done this, but it's beyond the scope of this course to teach you how to do equations. So I have no problem teaching how to do equations, but the thing is, we're going to want to do this outside of the class videos, okay? So what I strongly suggest that you do is if you have any problems, you email me and you say, hey, Mr. L, I'm kind of forgetting all about this stuff. Can you help me? And I'll do one of two things. I will either put up a video all about how to solve these equations, or you and I can talk during office hours. but one way or another, we'll get you the help you need. If you don't get the help on this, then what happens is you can understand everything about complementary, supplementary, adjacent, vertical. You can know it all, but you won't get the questions right. Not because you don't know the geometry, but because you don't know the prior or the prerequisite algebra. Okay, so let's make sure we take care of this and we get it completely done. All right, the next video is going to start with some questions all that involve algebra, and we'll show you how we apply this. Again, if solving equations are really difficult for you, you need to contact me or a friend and get down pat how to do these equations, and then the rest of it comes pretty easy.